Hello everyone, thanks again for coming. We are going to get started here today. My name is Brandon Boucher. I'm the Research Product Manager and Support Manager here in AD Instruments North America. Today we're going to be talking about priming and operation of your Radnoti isolated heart system. This is going to be a little bit different than what we normally do in our LabChart Mastery series. Typically we cover a LabChart feature. This time we're going to be focusing primarily on a piece of hardware, and we have a lot of questions sometimes about, what is the proper order of operations for maintaining and using the Radnoti isolated heart system, so we thought we'd take you through it today. So to get started here, we're going to go through our PowerPoint presentation, and hopefully you guys will be able to see this here getting started soon. The first thing we're going to talk about here during our webinar is just the way the webinar is going to work. All audio from the attendees will be muted, so I will not be able to hear you. But if you do need to communicate with me and you have any questions, please feel free and go to the Questions tab on your webinar, GoToWebinar toolbar, and type in your questions there. At the end of the presentation, I will come back to all of those questions and I'll answer them for you as I can. Before we get started in our actual webinar, we're going to be talking about what other training options we have coming up here. You're going to notice we have quite a few things. First of all, we have a course in April, two courses in April in Colorado Springs and in Boston, covering our LabChart levels 1, 2, and 3. And we also have, another course at the Jackson Lab that we help out with, the comprehensive approaches to the in vivo assessment of cardiovascular function in mice. That is a great course covering a number of cardiovascular assessment tools that you have available to you, and we help out with part of that. So I encourage you to look for that if you want to find out more about that course. Then we have another course in May in Colorado Springs as well. So if you're interested in learning more about our software or more about your hardware as well, we have a lot of options for you, and these courses offer you the opportunity to come out and visit with us for a couple of days and really get some hands-on experience with some of the experts we have available to you. So look forward to that if you get the chance to do that. Upcoming webinars, we only have one scheduled at the moment, and that's video capture on the 4th of April. As we move forward, we will be putting more events up on our events page, adinstruments.com/events. So if you want to find out about when these webinars are occurring, please feel free and go there and check that out. One more thing before we get started, we're going to be talking about just the Statement of Intended Use policy. This is just simply something that we always mention during our educational courses, and that is just simply to say that AD Instruments products are intended for education and research purposes only. That is to say that no AD Instruments product is intended to diagnose, treat, or monitor a human subject. That being said, some of our equipment is approved for human connection with the proper front ends. So look for those if you're going to be using those with human connection. We do have proper amplifiers with both body protection and direct cardiac connection approvals. We also manufacture our products under a quality management system, ISO 9001. We have a third-party company come in and actually verify this quality management system for us, and we're proud of that, so we do like to talk about that. One more mention here is you have the ability to follow us on your favorite social network. We are going to be beginning to announce more of our events there, so if you want to follow us on any of these channels, you can follow us and find out more about what we're doing both in the training realm as well as some of the other things that we're doing as a company. So take a look at those and please follow us there. So here's what we're going to be talking about today. We're going to be quickly going through first the parts of an isolated heart system. We're going to be working with images of a working heart system today. I'll try and explain the differences between a working heart system and a Langendorf system as we go along. So the images are going to be of a working heart system, but we're going to be trying to cover, all of the aspects of the different types of systems you may be using. So we'll be going through the different system parts. Then we'll be talking about system priming, the order of operations, and this is where some people, can lose just a few things in terms of how to use the system. It's really important before you begin using the system at all to know how to properly prime the system and make sure all the parts are functioning and filled in a way that they're ready for a heart to be attached. So we're going to be talking about that. Then we're going to be going through, with our working heart system, the different ways that we can manage the flow to create a Langendorf system, both in constant pressure and constant flow. And then we're going to show you the recirculating and non-recirculating options for the Langendorf system. We're also going to be showing you the working heart and how that works, the different configurations of the stopcocks and cannula that give you, the working heart apparatus. And throughout the presentation, we're also going to be just talking about a few tips and tricks that we do with our own systems here. So this was done, we took a lot of these images just the other day with a system we have set up in our own lab here. And we'll be showing you those and showing you just a few little changes and tweaks that we've made to help you out and make things a little bit better for your experiment. So keep an eye out for that. And we're going to be going through a PowerPoint presentation today, mostly going through images. So if you're watching this live, we're only going to be able to go through that. We're going to be going through images and show you the different configurations and everything else. If you want to look at a video demonstration of how to operate all of this with a live demonstration, we will be offline when we load this up on our video archive. We'll be trying to follow this up with a video demonstration so that you can see all of this process put together in a live video demonstration. Due to technical purposes, we couldn't put this into the live webinar version, but later on we will be adding a live video demonstration to what we're going to be going through here in the PowerPoint presentation. So look for that if you're interested in seeing the video demonstration as well. So before we get started, we're going to be talking about the different parts. The first part we have here is the pump. Obviously, we're going to be pumping with our working heart system. Our working heart system is, this is the actual working heart system we have in the lab here over on the right. And the pump is going to be both pumping the fluid to the atrial cannula, or the atrial bubble trap. It's also going to be taking the fluid in recirculating mode and also pumping it back to the oxygenating bubbler here. We're going to talk about each of those different parts and their purposes as we go along. The next part we're going to talk about is the reservoir. When we start the experiment, when we start the procedure, we're going to be drawing from the reservoir to start with. You'll notice that the fluid here that we have in our system is bright green. No, this is not a special concoction of a buffer that we have that we use here at AD Instruments. This is just simply some water that we put some green food coloring in so we can make it easy for you guys to see when we take pictures of this and everything else, so you guys can see where this fluid is moving. So this is just simply some DI water with some food coloring in it. So the reservoir, we're going to be drawing the fluid from that reservoir. The oxygenating bubbler serves an interesting purpose. If you're going to be doing recirculating mode, and this is the oxygenating bubbler is used in a rat system. We'll replace that with a membrane oxygenator if you're going to be doing mice. But in a recirculating mode, this is going to be the place where we hold our excess buffer so that we can do recirculating mode. We have the atrial bubble trap in this system. Again, this is a working heart system. If you have a Langendorf system, we will be skipping this altogether. We'll be moving directly from the pump to the aortic bubble trap. But in the case of this working heart system, we have the atrial bubble trap as well. So the only difference, again, between the Langendorf system and the working heart system, if you're looking at the difference between your system and this one, is just simply we skip this one altogether. This one just isn't there, and the tube here that goes up to that system, I'll highlight it here for you. The tube that goes up here to that system here is just going to simply extend all the way to the aortic bubble trap in a Langendorf system. So that's the only difference in terms of what you see here. The next part is the aortic bubble trap. Of course, we're going to be using this as a staging area for our buffer before taking it to the aorta. So the fluid will come up through this tube here on the right, or on the left, and come down through this tube here on the right. And then finally, the last couple options we have here, we have the heart chamber and buffer reservoir. So obviously we have the cannula here with the heart chamber. This is the heart chamber for rats. And then we have a buffer reservoir that's going to allow us to hold a little bit of fluid in this place if we're recirculating to keep us flowing back throughout the system. We're talking about how to we'll talk about how to use and operate all of these different parts as we go along today. And then lastly, we have the compliance loop. If you have a Langendorf system, you're not going to recognize the compliance loop. The compliance loop is going to be used in a working heart mode only. This is what we use for the heart to beat against in working heart mode. So when the left ventricle fills with fluid and pushes out against the afterload pressure is set by the compliance loop, and it also allows us to put a bubble in the path there, or in the water column, so that we give some compliance to the heart as it beats against it. So we're going to be talking about how to use that as well. And before we jump into the different modes and everything else, I'm going to talk about the two different stopcocks you're going to see in this presentation. We have the three-way stopcock here, and in both of these stopcocks, the port that are connected to the stopcock are open if the arm of the stopcock valve is pointing in that direction. So in the case of this three-way stopcock, this is open in this direction, coming to the top of the stopcock right here. So this is open. This is open here as well. And this area over here is closed. So we talk about closing the flow from a port here later on. We're going to make sure that there's no arms pointing in that direction and that it's closed. This stopcock here is in the closed position. You can tell because the arms are not pointing in the direction of either of these ports. If we were to turn this 90 degrees, then it would be pointing in the correct direction, so the fluid could flow through this. And so these are the two stopcocks you're going to be seeing throughout the presentation. So we just wanted to make sure that we knew what the positions actually mean. So what we're going to talk about now is just priming the system, how to fill the system. And we'll mention again, if you have a Langendorf system and not a working heart system, just the difference between what you're going to be doing here. The main thing that you have to do here is first you have to fill the system basically in a linear fashion. So the first thing connected to the pump here is the atrial bubble trap and the atrial cannula. So that's the first thing we're going to fill with fluid when we're priming. In order to do that, what we're going to do first is we're going to close both valves, both exit valves, besides the normal perfusate route. We're going to close the venting port as well as the overflow valve. We're going to close both of those before we start priming the system. And that's on the atrial trap. So you can see here in my two images, I'm going to do my best during this presentation to highlight the portion of the system we're talking about. So this is the atrial bubble trap, and both ports are closed to start priming the system. The next thing we have to do is we have to actually open the atrial cannula. So what you're going to see here is we have fluid coming from the atrial trap, okay? And this is the port that comes from the atrial trap. So if you look at the atrial trap in the larger image, this is the atrial trap. The fluid will come here. It will come out of the atrial trap, and this is what you're seeing here in the second image, is this port coming up. And that's right here. And this is connected to this stopcock here. It's coming behind the other one, and it's connected here. So in order to start priming the system, before we start, we're also going to allow the fluid to come through this port and down the atrial cannula. We're going to turn the pump on, and what's going to happen is we're going to make sure that we're drawing from the reservoir. So that means the fluid's coming from the reservoir, and it is going through this stopcock here next to the oxygenating bubbler, but we're not going to be drawing from the oxygenating bubbler. As of right now, we're only drawing from the reservoir. We're going to draw from here. The fluid's going to come through the stopcock, and you can see it's open in this direction, and the fluid's going to come in this direction from the pump, and we're going to fill those different ports that way. And you can see now, hopefully, that we see the green where the fluid has come through. So the fluid has come through here. We've gone through the pump. We've pumped up to the atrial bubble trap, down this tube here, and down the atrial cannula. So we have all of this filled with fluid, so we have to allow that section to fill. The next step, you can see here we have just a closer picture. You can see that this is filled. The atrial bubble trap itself has not filled all the way. We simply are just taking the fluid, pumping it here. It's pumping directly down this way and down through the atrial cannula. So the next thing we're going to do here is look at the next step in the process. After that part's filled, we're going to turn the pump off. The next thing we're going to do is we're going to stop the fluid flow in this direction. Before we had the flow going through the atrial cannula this way. You can see I turned this stopcock here so that now this port is stopped and the fluid can no longer go this direction. And because we did that, we can then open the atmospheric port on the top of the atrial bubble trap. If we turn the pump on at this point, what happens is because that fluid is stopped over here, this will then fill because we have this open atmosphere. So we're going to fill this. As soon as the bubble trap is filled, we're going to close that port and turn the pump off. So now what we have is we have everything filled up to the atrial cannula, and we have this part here filled as well. The atrial bubble trap is filled up to 2/3, or right up to the exit port or the overflow port. If that's all filled, you're in the right spot. So one thing to mention about this, we have filled the atrial bubble trap and the atrial cannula, but just note, if you don't have those parts, if you just simply have a Langendorf system, this step that we're about to do is the first step. We're going to fill the aortic bubble trap and cannula. So just keep that in mind. In order to fill the atrial or the aortic bubble trap and the aortic cannula, we're going to set the cannula up in this fashion. Now this is hopefully will make sense as I go through it. I tried to do my best to label these and make sure you could see the direction everything is going. So if you have questions about this, you weren't clear when I explained this, just let me know and we'll come back to it later on. So the fluid is coming, so the way that these are set up, the fluid is going to come from the atrial trap because, remember, going back to our prior images, we had closed the atrial bubble trap again. This is closed, okay? So we closed it, we turned the pump off, so now everything should just be sitting there with those two parts filled. The next thing that we're going to do is we're going to pump that fluid from this port up to the aortic bubble trap, okay? So in order to do that, we're going to see the fluid coming from the atrial trap, and we're going to set this stopcock so that it comes from the atrial trap and goes up through this tube here around the loop and up to the aortic bubble trap. What you're going to notice if you are doing a working heart system right now, if you're doing a working heart experiment, what you're going to see in my system is that the aortic cannula, or the aortic cannula is on this side here, and the atrial cannula on this side are reversed to what you might have set up. In our experience, having them in this order with the aortic cannula on the left and the atrial cannula on the right is advantageous to the working heart experiment because it makes it a little bit easier just in terms of geometry to get this atrial cannula into the right place. But anyway, so moving on in what I was talking about, we have from the atrial bubble trap, the fluid's coming up here. We also have this port set so that this fluid coming from the atrial trap is going to the aortic trap up through this way. So you can see I have the same things marked here. We're going to come down this way from the atrial trap to the aortic trap. And then we also have this closed. So make sure we have this closed. In the same way we did down here with the atrial trap, we have this closed. And you can see that in my next slide, that will be closed. The fluid coming from the aortic trap is going to come down its tube and come to here. It's going to come through this little loop, and it's going to go straight down into the aortic cannula. So we want to set that up in that fashion. So the fluid's going to come here. It's closed to the atrial cannula. And you can see that these arrows are what's labeled. So this says to aortic cannula, that's to the green arrow. This is the aortic cannula here. The fluid's going to come from this way up to the aortic trap, down from the aortic trap, and down the aortic cannula here. Okay, so that's the order and the fashion we want to do this. Remember, I had mentioned the aortic trap is closed during this priming process, so the fluid's going to come up this way. It has no choice because everything's closed, but to come back down and come through the aortic cannula. Turn the pump on, fill everything up. You can see that it's filled. The next step is to stop the flow, because remember, what we've done is we've filled the tubing. We have not filled the bubble trap. Okay, the bubble trap will remain relatively empty. The fluid will simply drop down and go down into the aortic cannula. In order to fill this section, we need to stop the flow, and this stops the flow going into the aortic cannula. Then we open the port on the top of the aortic bubble trap, and what you're going to see is the fluid will rise to the top of the aortic bubble trap. One thing to mention about the aortic bubble trap and both bubble traps, actually, the aortic and atrial that we've mentioned thus far, is that both have a syringe on top. We have found that putting those syringes on top, and those syringes have the plungers taken out of them. So essentially all they are is a tube that's connected on top of these. This gives us a little bit more wiggle room. If you've ever been using either of these bubble traps in constant pressure mode, what you may find is that you may have overflowed over the top. By putting these syringes on top, it gives you a little bit more wiggle room for that thing to fill a little bit before you drain through the overflow port. So we'll mention that again as we go along. But I just wanted to mention that because it's in this image here. But in order to fill this, we're going to open this port. It will fill the aortic bubble trap, and the next step will be to close that port and turn off the pump. So this will be filled. The tube is already filled. All of this is ready to go. And now what we have is we have the next, at this point we will have both the tube going to the atrial bubble trap filled and the tube going to the aortic bubble trap filled. Lastly, we're going to fill the compliance loop if you're using a working heart system. In order to fill the compliance loop, it's pretty straightforward. What we're going to do is we're going to leave this in the same direction that it is. So we're going to leave the atrial stopcock in its same direction. So we're going to go from the atrial trap to the aortic trap, and then from the aortic trap we're going to change this stopcock so the fluid goes to the compliance loop. As we do this, because we have both, remember we have both of the bubble traps completely closed at this point. If I go back and just look at this other image, we have both bubble traps completely closed at this point. If we move forward and we look at this image, both of those are closed. That means all the fluid is coming all the way through the loop. It's coming down this way to this stopcock, and then it's going up to the compliance loop. And that's the way we're going to fill the compliance loop with fluid. There's a little bit more to the compliance loop, but we'll talk about that at the end of the presentation. But we're going to fill it that way. The last step in the priming process is to allow the recirculating reservoirs to fill. If you are going to be recirculating, you want to fill those reservoirs with a level of fluid. And what you can do is, if you're doing a working heart, the compliance loop will easily fill this, or you'll just simply have one of your drain valves or something going to this port so you can fill this. There's various ways to do it, but typically what I do is, while I'm priming the compliance loop, I just step one back here, I just allow the compliance loop to drain to the recirculating or the oxygenating reservoir here, and that will fill it that way. So allow those to fill if you need those. System is now primed, yet we are not quite ready for the heart. You can see this is an image of my system primed, and hopefully you guys can see in this image all of the green tubing. That's why we made this this fluid green with food coloring, so you can see all of this tubing filled. But all this is filled with fluid and ready to go. We're not quite ready for the heart yet, because what we need to do in order to get the heart on is we need to actually put the system into Langendorf mode. We need to put it in constant flow Langendorf mode. And that's what we always recommend before you hang the heart, is to put it in constant flow mode. Even if you're going to do constant pressure Langendorf, put it in constant flow mode first. so you have a stable, ready-made amount of fluid coming out of the aortic cannula and ready for the heart to be placed onto the aortic cannula. So in order to get into the first step, which is the constant flow Langendorf, what we're going to be doing is before the heart can be placed in the system, we must switch to constant flow Langendorf. So what we're going to do here is the first step is to leave the bubble trap closed. The aortic bubble trap is still going to be closed in constant flow Langendorf. We still have a little bubble up here. It's filled. We have a little bubble of air up here, but both of these ports are still closed so that in constant flow, all of the fluid coming this direction is coming out of that port, and the amount of fluid that the heart accepts is maintained by the flow of the system. So you're going to want to set this in the proper flow rate for the heart you're going to be hanging on this system. Once you have both of these closed and you have the pump going in the speed you'd like it to, you need both of these closed actually. So the atrial bubble trap will also be closed in the same fashion so that all the fluid going in will go out of the system. In order to do constant flow Langendorf, what we're going to be doing here is we have the fluid coming from the atrial trap to the aortic trap. If you don't have this, remember, if you don't have the atrial trap, this connection is already made for you. This is going to be one consistent tube that comes from the pump all the way to the aortic trap. You don't need to worry about this part. But if you have a working heart system, we're going to go from the atrial trap to the aortic trap, and from the aortic trap, we're going to have this stopcock open so that the fluid coming here is going to go straight down into the aortic cannula, which is what we see here on this image on the left is the aortic cannula. So the fluid, all of the fluid is going to be pumping from the pump all the way through the system because everything's closed and coming straight down this cannula. Now the system is ready for the heart. Okay? If you have this in constant flow Langendorf, your system's ready for the heart. So remember, you want to set this flow rate to the right flow rate for your heart, but once you do that, you're ready for the heart. Now, once you have the heart hanging, if you're doing a constant flow Langendorf, and that's your experiment, you're ready to go. There's nothing else you have to do at this point. But we're going to go through all the other steps and all the different ways you can change the way this system is maintained and operated. So the first thing we're going to go through is the one thing or the two things we need to change in all operations if we want to recirculate our perfusate. Okay. So in order to do this, and these are the things that need to change in all operations if we're going to recirculate our perfusate. To start off with, when we're running the system and priming the system and we first have it in constant flow Langendorf and we're ready to go hang the heart, we hang the heart. In all of those steps, typically we're going to be dumping all of our excess fluid off to waste. So you can see here my stopcock is set. So the fluid coming off of the heart chamber and down this reservoir here is going off to waste. Okay, and that's how we have it set up here. In order to switch to recirculating, what you're going to want to do is you're going to want to change this and change that stopcock configuration so the return goes to the oxygenating bubbler. This is going to go to the pump here, actually, directly. It's going to go to the pump. The pump is going to pump it back up to the oxygenating bubbler. And then what you're going to want to do also is in most of those circumstances to start out with, we're going to be drawing fluid from the reservoir. Just like what this image shows, we have the fluid coming from the reservoir, coming through here. This stopcock draws the fluid only in this direction from the reservoir and to the rest of the system. What we're going to change if we want to do recirculating is we want to change it so that we're drawing from the oxygenating bubbler. Remember that the perfusate coming off the heart is going to this through the pump as well. It's coming in and refilling this reservoir. We're going to draw from this reservoir and pump that stuff to the system. Okay, the next step here is we are going to change this to constant pressure Langendorf if we want to. In order to do that, this is an image of what we're going to do to change our constant. So we're in constant flow Langendorf right now, and we're going to change this to constant pressure Langendorf. And specifically constant pressure non-recirculating Langendorf. In order to do that, we're going to open the top of our aortic bubble trap to atmosphere. So you can see this is open. This is just a syringe on top. You can see there's a syringe on top of this. That syringe has the plunger taken out of it. We're going to put that syringe on top, This is open atmosphere, and the drain valve is going to be opened so that this port is going to the reservoir. And this will self-balance. You can see I'm up here a little bit higher than I need to be, but this will self-balance. As the port here going to the reservoir starts to drain, this will balance off very nicely, and you'll have a nice and consistent pressure head to go against the heart in constant pressure Langendorf. Again, this is non-recirculating. If we want to do recirculating constant pressure Langendorf, what we're going to do here is we're going to leave this in the same configuration where we're at vented atmosphere. Remember, this is up here we're talking about, right? If this is vented atmosphere here, the pressure against the heart is maintained by this fluid column coming all the way down here to the aortic cannula. Okay? But looking at this, we have two things we're paying attention to for constant pressure recirculating is that we have this open atmosphere for the constant pressure. For recirculating, instead of taking the fluid back off to the reservoir, we have this drain stopcock set, so we're taking it off to the oxygenating bubbler instead. Remember the oxygenating bubbler being this part down here. Okay, we're drawing the excess fluid from the top here. The excess fluid as we're pumping is going to come off here. One important thing to note if you're doing constant pressure Langendorf is that the flow rate here needs to be set at a high enough rate, just simply higher than the flow rate that your heart is accepting. Okay, all the excess will drain off. Okay, you don't want to go much higher. You don't want to go tenfold the flow rate that your heart is accepting. But if you're 2 or 3 times, or even double the flow rate your heart is accepting, you're in a good range, and all the excess fluid is going to drain off here, and you'll simply maintain that pressure head very well. Okay, so this is constant flow, or this is constant pressure Langendorf recirculating. We have the atmospheric pressure here, and the drain port going off to the oxygenating bubbler, and that is this here that we're talking about, the aortic bubble trap. Now, to switch to working heart, what we have to do is a little bit more complicated, but not terribly. What we're going to be doing here is we're going to be taking now. First, we're going to talk about the cannula settings. Okay, we're going to set the cannula up in the right configuration. So you have the aorta and the pulmonary vein, the right atrium set up, the left atrium set up for working heart. So the aorta and everything is connected here. And what you're going to do is then switch this flow so that instead of going from the atrial trap to the aortic trap going up, what we had configured here when we were in Langendorf mode was for this flow all to go here, come through this tube, and not go down this way, but rather go up to the aortic trap. Instead, for working heart, what we're going to do is we're going to switch this so we're going from the atrial trap through this port and down to the atrial cannula. The heart is there now, so the heart is going to accept that fluid, and it's going to begin to pump it up through this aortic cannula. And what we're going to do with that is we're going to simply just switch this over so that we're going from the aorta to the compliance loop. We're going to ignore the aortic bubble trap completely in this instance. So in working heart, we're coming from the aortic cannula to the compliance loop, forgetting about the aortic bubble trap. Okay, so hopefully that makes sense. In the next step, we have to set our bubble trap. Remember, we're ignoring the aortic bubble trap because we're in working heart mode and we're using the compliance loop. So what we need to do is just simply set the bubble trap for the atrial bubble trap in constant pressure mode. We want to set this in constant pressure mode. So we're open atmosphere here on top. We are draining the fluid off to the reservoir, and this is in working heart non-recirculating mode. In working heart recirculating mode, we simply have the same thing, open atmosphere on top, draining to the oxygenating bubbler on the overflow port. Okay, so that's working heart. Now, the aorta is going to be pumping against the compliance loop. Remember, going back to our other images, we'll get there here in a second. Going back to our other images here, we have the atrial trap. From the atrial trap going to the pulmonary vein, and the heart is accepting that fluid, pumping out of the aorta, and we have this going directly to the compliance loop. Okay, remember that. So the other option here is we have the fluid coming from the aorta going to the compliance loop, and the compliance loop here is going to be what's setting both the pressure head but also the compliance of this system that's going to try and mimic the compliance of the arterial vasculature. So in order to do that, what we have to do is we have to actually adjust the compliance loop. Okay, so the compliance loop is not just simply something that you're just going to set and forget. Once the heart is pumping against it, you do have to adjust it to get things right. And I'll try and explain why you might adjust this. So the adjustment, you can see the compliance loop is made of two parts. Okay, so this is where it sits on the entire system, but there's two parts here. There's the compliance bubble trap here. This one has a closed syringe on it, so I did not take the plunger out of this syringe, because we're going to use that syringe to adjust the compliance. It has this part here, and the fluid is pumping through there and up to the reservoir that's on top, and that's what's maintaining the pressure head, and then all the excess fluid is then draining off into the system, or back. Typically, we'll just drain it back off into the reservoir here. So what I'm going to do next is talk about why you might adjust this. So in this section here, the compliance bubble trap is where you might adjust the amount of compliance the heart is actually seeing. So the left ventricle will begin to beat against the set afterload pressure. Remember, the afterload pressure is set simply by the height. If we go back here, that afterload pressure in working heart mode is just simply set by the height of this chamber here. So that tells you how much fluid there is in this fluid column that is against the aorta. Remember, in working heart mode, we're accepting fluid from the atrial bubble trap. Fluid is going into the heart, and then we're pumping it out of the aorta, and we're pumping it into the compliance loop here, which, again, sets the afterload pressure. The compliance may be adjusted by changing the amount of air inside the compliance bubble trap with syringe. So this next image is simply going to show you what that looks like. So here I'm just showing three different levels. One level here in the middle, I've taken all of the air out of the compliance loop. Now there's no compliance in that chamber. But these two different images on either side, the left and right, show images of different levels or different amounts of air inside the fluid. And you can adjust very specifically the amount of air that's inside this bubble trap simply by noting where your syringe is marked, right? If you have a graduated syringe, you can see how much air you've pushed in or pulled out of that bubble trap. Now, the adjustment really is a matter of really trying to, again, model the compliance of the vasculature. And one of the things you can see, if you don't have enough compliance, oftentimes what happens is you just have a really high resistance that heart is trying to beat against if you don't have enough compliance. And what you'll see in that instance is that, you know, the valve may open, you may just barely reach inside the ventricle, you may just barely reach the pressure of the afterload pressure you're putting against the heart. But in order to create a flow against that, you know, the heart may just not have enough to push against that. So you may see, you know, it reach the afterload pressure, but you may not exceed the afterload pressure like you normally would in normal physiological system. You know, that left ventricle is going to exceed the afterload pressure and push fluid out. And if you're not seeing fluid being pushed out of the system, what that's telling you is you're not actually, when you open the valve, or if you even do get to the point where you can open the valve, you're not pushing fluid through the system. And that can tell you that you don't have enough compliance. So you may need to increase compliance at that point. And you know, there are various reasons why you might decrease compliance, but really what you want to do is you want to put this bubble trap in a place where you have the right amount of compliance. And really, you know, the way you can tell you have the right amount of compliance is the heart is operating as expected. You know, you have normal physiological signals both in the afterload pressure and in the left ventricular pressure. So that's the idea. So we're going to adjust that and make that right as we go along. So that's what I wanted to show you today. Those are all the steps: priming the system, operating the system, and going through everything. Now, again, we're going to follow up this, hopefully, if you guys watch this in our video archive later on, if you want to come back and review this. We'll hopefully follow this up with a video demonstration where I will actually go through and do all of this process with a real system. Again.
Hello everyone, thanks again for watching. This video will be a supplement to our recent webinar, Priming and Operating Your Radnoti Working Heart System. And what we're going to be doing is we're going to be doing a demonstration of what you just watched. We went through all of the different priming steps and operational steps for using this system. And what we're going to do is we're actually show you those things live and do a demonstration of those things. So to start off, what we're going to do is we're actually going to prime the system first. In order to do that, we're going to start off simply by priming the atrial bubble trap and the atrial cannula. To do that, we're going to make sure our valves are in the right position. So our valves here that we're worried about are those on the atrial bubble trap. On the atrial bubble trap, what we want to see is we want to see both valves closed. So all of the fluid coming to the bubble trap is going to move through the cannula. The other thing we want to make sure we do is we have the atrial cannula set so the fluid coming through this tube here to the cannula is actually going through the cannula and nowhere else. So we have that set properly as well. So what we're going to do now is we're going to turn the pump on. And we'll watch it fill that part of the system. As soon as it gets to the point where we're seeing fluid coming out of the atrial cannula, we'll be ready to stop there. And I usually just turn the pump speed down so that I can adjust things and turn it back up as needed. So the next thing we'll do is we want to stop the flow going through the atrial cannula. So what we want to do is fill the atrial bubble trap here. So we'll stop that flow going through the cannula so the fluid coming down here is hitting against the valve and can't go anywhere else. We'll open the atmospheric valve here on the atrial bubble trap, turn the pump on, and we'll watch that fill. As soon as it gets filled 2/3 of the way, or right alongside the overflow valve, we'll stop that flow and we can close the atmospheric port on the atrial bubble trap. The next step is to fill the aortic bubble trap, or fill the lines to the aortic bubble trap rather, and fill the aortic cannula. So in order to do that, at this point we're already set, but before we turn the pump on, I just want to go over those things with you. So what we need to do is make sure that both valves are closed, just like what we did here before. Both of these valves are closed, and our valve is open to the aortic cannula. So if I turn that on, oh, we need to do one more thing I didn't mention, sorry. What we need to do is actually switch this valve so that we take the fluid that's coming from the atrial bubble trap, goes up to the aortic bubble trap. So as soon as we turn that on, we should see fluid going up. We should then see it go back down and through the aortic cannula. As soon as that is done, we'll stop our flow one more time. You can see those tubes are filled. And what we need to do now is fill the bubble trap itself. We'll do the same thing. We'll stop the flow here. So the flow is stopped going through the cannula itself. We'll open this port to atmosphere, and we'll start the flow here. And we'll see that one filled as soon as it's 2/3 of the way up, or right in line with the overflow port. We'll be ready there. We'll stop that. We want to close this port one more time. So we'll close that port. And now we have most of the system filled. The next part of the system we need to fill is the compliance chamber, or the compliance loop. So in order to do that, the fluid is now coming. It's closed here, it's closed here. The fluid is coming through the entire circuit, and it's coming to the aortic cannula. So at the aortic cannula, we want to change the valve so that we're going up and through the compliance loop. As I change this to that direction, we're going to be ready to go. I'm going to turn my pump on here, and my pump will pump our fluid up to compliance loop. And what I can do to ensure that the compliance chamber, as soon as this part's filled, and you can see we're going to start dropping fluid off into the chamber itself. As soon as this part is filled, what we can do to fill the compliance bubble trap is we can actually just simply pull off this syringe that we're using. The syringe we're going to use later on to actually control how much air is inside the compliance loop. But at this point, I'm just going to pull it off so we can fill that up. Now all of our fluid should fill the rest of the compliance loop, and we'll be ready to go. A couple things that I want to mention about our system here that you may have noticed is that first we have some syringes. We have some open syringes on top of the atrial bubble trap and on top of the aortic bubble trap. The reason we have that is just to give us a little bit of room, a little bit of headway, so when we switch these and we open these to atmosphere, we never overflow. We have a little bit more room to allow fluid to open up in there. The other thing you'll notice is we have a syringe on top of the compliance loop that's going to allow us to adjust the amount of air inside the compliance loop. And the other thing that we have is, you'll notice, if you're familiar with the working heart system, this may be a little bit different from what you've seen before. Our atrial and our aortic cannula are in opposite directions from what you might see in the manual. We find that oftentimes when hanging a heart, it's a little bit better for the geometry of the heart for you to be in that direction with the aortic cannula on the left and the atrial cannula on the right. And so ours is a little bit different in that respect. So everything is primed now and we're ready to go. So what we're going to notice is at this point, the next thing, or the final thing that you want to prime, if you want to prime the rest of the system, is you want to prime the recirculating parts if you're going to be recirculating. There's a number of ways you can do that. Normally, if I'm going to prime the oxygenated bubbler, the only thing that I'll do is I'll put more fluid through the compliance loop, and that actually will drain into the oxygenated bubbler here, so I don't have to do much else to fill that. And if you want to fill the buffer reservoir here, you can simply let fluid go through the cannula and fill that as well. So as we're going along here, you're going to see this fill, so I'm not going to worry about it at this point, but we'll use it later on as it fills, as that fluid from the compliance loop falls down into the oxygenated reservoir, or the oxygenated bubbler. So at this point, what we can do is we're ready to get ready for the heart. The system is primed, and we need to get ready to put the heart on. In order to do that, we're going to put the system into constant flow mode, constant flow Langendorf mode. So to do that, what we want to do, essentially the only change we're going to do is we're going to make, instead of the fluid coming through the entire circuit and going into the compliance loop, here we're going to make it so the fluid comes through most of the circuit, through the aortic bubble trap, and goes through the aortic cannula. So the only valve we need to change to put it in constant flow Langendorf is change it so the fluid coming from the aortic bubble trap goes through the aortic cannula, and we can turn it on and we can see that that's happening. You'll want to make sure you wait for any bubbles to exit the system before you put your heart on, and you want to adjust this flow rate so that it's about right for the heart you're going to be putting on. And you'll want to put the heart on at this point in constant flow Langendorf before switching to constant pressure Langendorf or anything else. And the reason is because if I were to switch this to constant pressure right now, I'd lose the fluid out of my system. So at this point we are ready for the heart, so we can hang the heart at this point, and then we're ready to switch it to constant pressure Langendorf or to working heart if we need to do that. So at this point I'm going to demonstrate, now that we're in constant flow Langendorf, we're ready for the heart, we have some fluid down here in the buffer and the oxygenating bubbler. What we're going to do is we're going to demonstrate switching this from constant flow non-recirculating to constant flow recirculating. The only change that we have to do is to change where the fluid that's coming off of the heart is going and where we're drawing from in constant flow. There's a couple other changes in the other procedures, but in this one we don't have to do much else. So what we're going to do here is we're simply going to change, the valve here is simply changing the fluid that's going from the heart to the waist. We're going to change that so that we're going to take that fluid, and through our second pump head we're going to pump that back up to the oxygenating bubbler. The other thing that we're going to do is we're going to change our draw point. We're drawing from the reservoir right now, we're going to draw from the oxygenating bubbler. So to switch that, we'll simply turn our valve so we're no longer drawing from here, we're drawing from here, and now we have a closed circuit. We're drawing from the oxygenating bubbler, and any fluid that we get from the heart, coming off of the heart, is being pumped back to the oxygenating bubbler, so we have a self-contained system. So that's recirculating. The next thing we'll do is talk about how we're going to do constant pressure Langendorf. In this case, I'm going to switch this back to a non-recirculating mode before I go and look at the constant pressure. So I'm going to draw again from the reservoir, and I'm going to take my fluid off the waist coming out of the heart. Switch this to constant pressure is pretty simple. All we need to do, this is going to be again after the heart has been placed on the system. We're going to switch this over, and in order to do that, we're simply going to take two valves in the aortic bubble trap and change their configuration. We're going to first change the top valve here is atmospheric. We're going to change the overflow valve so that it's going off either to the reservoir or to the oxygenating bubbler. So I'm going to change those two ports. First, I'm going to change this to atmospheric. I'm going to change this valve so any overflow or extra fluid we're pumping to that part of the system is coming off, and now it's going to the reservoir. So at this point, if you switch this over, you should be just mindful of your pump speed. You want that pump speed to be just high enough to keep that bubble trap filled and still push fluid through the heart. So once you find that nice, set pace, it should be pretty consistent. So I think I have that set pretty well, and now we're in constant pressure Langendorf. All of the extra fluid that I'm pumping up here is coming off to the reservoir again, and the heart itself is setting its own pace as far as the fluid that it's taking in. So now what I need to do is talk about how we want to switch this over to recirculating. In recirculating mode, what we want to do is simply do the same things we did before. We switch these two valves so that we're taking any extra fluid and we're pumping it back into the oxygenating bubbler. We'll draw from the oxygenating bubbler, and then we'll want to switch the overflow port. The overflow port right now is going to the reservoir, and we'll want to switch that so that it's going instead to the oxygenating bubbler. Okay. So that's the only thing we really need to change as far as going from recirculating to non-recirculating, just where the fluid is going. Wherever we have extra fluid or anything else, we'll just want to change where that's going to. So the next thing we'll want to do is we'll want to talk about switching this to working heart mode. So we're in constant pressure, everything's working fine, we're in recirculating. So I'm going to switch this back to non-recirculating, then we'll talk about what to do and to switch it into working heart mode. So I'm going to switch this to draw from the reservoir one more time. We're going to take this and we're going to draw to waste. And in looking at this, the only real change that we're going to do to get this into working heart mode is first we need to make sure that the atrial bubble trap here is set to constant pressure. The atrial cannula is taking fluid to the heart. Then the heart is going to be ejecting fluid out of the aortic cannula and to the compliance loop. Okay, so these are the changes we're going to make. In order to make these changes, first what I'm going to do is I'm going to adjust the heart. I'm going to set the heart so it's up in working heart mode. And then I'm going to adjust the flow so that it's going through the atrium and into the and out of the ventricle and out of the aorta. So I have a little mock heart here that I have just set up with a piece of tubing. So to switch this over, I'm simply going to connect my tubing so we have those two set together. Now I need to change my flow so that my flow from the atrial cannula is going through the atrial, or from the atrial bubble trap is going through the atrial cannula. So I'll switch that here. And then I need to change this so that any fluid going out of my aortic cannula is going to my compliance loop. So those are my two settings. Those are what I need to change. And then lastly, as far as these are concerned, that's all I need to change. Lastly, I need to change the atrial bubble trap to constant pressure. Okay. I'm not going to change this to constant pressure because at the moment I have a piece of tubing being used as mocking up a heart. And so if I change this to constant pressure, we're gonna lose some pressure in the system. It's going to go the wrong direction. But normally in your circumstance, if you have a heart hanging that's functioning, you'll change this atrial bubble trap to constant pressure so that everything is working the way it should. The last thing we'll talk about here in terms of working heart, now that we're in working heart mode, the fluid coming into the atrial bubble trap is set at constant pressure. We're taking this fluid off into either the reservoir for non-recirculating or into the oxygenating bubbler for recirculating. And the last thing we need to talk about is how to set up the compliance loop. So the compliance loop is what's going to determine how much, compliance your system is going to be mocking up for the heart that's going to be on there. So normally, if you didn't have the compliance loop, you'd have a very static pressure head against the heart and a fairly high resistance. The compliance loop is putting a bubble in that system so that your heart can beat against a little bubble. It has a little cushion, and we can adjust how much cushion that actually sees. And the way you'll want to determine how much will be in there, you'll see it in the literature, but you'll also determine it basically by how much that how well that heart can overcome that afterload pressure and whether or not you think you're having issues with resistance. So to adjust this, it's really simple. All we need to do is open the valve to the syringe we have here. I can pull some fluid out of that compliance chamber so I have a small bubble, smaller than what I had before. And then I can close that valve so that now we have a closed system with a small bubble in it and we're beating against that constant pressure head just like we want. So that's what we wanted to get through in the system, and just doing a demonstration of all the different operational features and priming the system. I hope you guys got a lot out of this, and we'll see you again next time.